Hello, my name is Gopal Ashok. I'm the product manager for Cloud Memorystore. Today, we're going to talk about optimally deploying an application cache with Memorystore. So let's begin. So there are a few areas that I wanted to cover today. So I'll start off with talking a little bit about why it is important to have an in-memory store in your application architecture and what benefits it provides. From there, we'll talk a little bit about Redis and why Redis is one of the most popular in-memory stores today. And from there, we will dive into Memorystore. Start with the overview of the product. What are some of the key features and capabilities that we provide? But more importantly, the key thing that I would like you to take away from this presentation is what are some of the best practices that you should be using when you are deploying Memorystore for your application use cases. So I think we all know in-memory stores are a critical part of modern application architecture, but let's take a close look at why that is the case. Without storing data or storing and processing data in memory, it is impossible to get the speed that is required by applications today. And we all know that the speed of the applications and the response time of the application essentially determines user retention, which essentially means it translates to how well your business will do. So having an in-memory store that can deliver the speed that is required by modern applications is super critical. The other aspect of it is that speed also in a way, or lack of speed and also in a way translates to availability. Right? If the website is super slow, that essentially means the website is unavailable. So again, an in-memory store allows you not really just to have the speed that is needed by the application, but it's also a critical component to deliver on the availability that is required by the application. The other key aspect where in-memory store comes into play, along with speed and availability, is cost. So there are a lot of use cases where you can benefit from having an in-memory store in front of your database or a backend store, for example, that allow you to reduce the cost or the total cost when it comes to data access. So by querying a lot more data from the in-memory store, you can actually provision or downsize or right-size your backend store provisioning, which can help you manage the overall cost for the data access. So as you can see, in-memory store is a super critical component which allows you to enable your application to scale and provide the speed and the responsiveness that the application needs. It allows you to have better availability, and also helps you manage the cost. So if we take an example, which is a very common example of user sessions or using or a session store, typically what happens in these scenarios is that you start off with using a backend database as your session store. And for example, if let's say your application is a ticketing application, and if you're using a backend store for a backend database as your session store, it'll scale well for a certain amount of time. But once your application takes off and you get thousands or hundreds of thousands of concurrent connections, you will notice that your backend store or backend database, for example, Postgres, is not actually going to scale. And this is where having an in-memory store in the architecture really, really helps. So you can store your sessions in the in-memory store. And basically, because the processing time and the processing is done in memory and the processing happens within milliseconds, your overall latency for the application can come down from hundreds of milliseconds in the 90th percentile to maybe tens of milliseconds for the 90th percentile. So having an in-memory store for scaling your application architectures is super, super important today. So let's take a look at what are some of the popular choices when it comes to in-memory store. I think when you look at usage, there's no argument that Redis is the most popular store today. You can argue most applications, regardless of industry or vertical, use or can benefit from Redis. And the popularity is reflected in DB Engines, which is a popular website for rating databases, and also in this Stack Overflow survey where users, developers, and DevOps folks rated Redis as the most loved database. So it's super clear that Redis is a very, very popular database or in-memory store that is used across applications today. Why is Redis so popular? Redis is an extremely fast in-memory store that provides sub-millisecond processing, but more importantly, it provides rich data structures that allow application developers to do computation, fast computations of applications logic on the server side. On top of that, Redis also provides capabilities like PubSub and streaming, which allows developers to build queuing applications, streaming application, and that too at a very high scale. Apart from that, Redis also provides a high availability and scaling features that allows Redis to be used across a wide variety of use cases at varying scale. So altogether, Redis has become the number one choice for in-memory stores for building modern application architecture. So if you're migrating to GCP or building new applications on GCP, Cloud Memorystore provides you a fully managed Redis and Memcached service on GCP. So if you are either migrating your application from on-prem, or if you are migrating an application from a different cloud, or if you're managing your own Redis on GCE, you now have a fully managed Redis and Memcached service that you can use to deploy your Redis and Memcached instances. I think that the key thing about having a memory store as a fully managed service is that it takes away the burden of managing the caching infrastructure. So let's take a look at some of the key features and capabilities of Memorystore. At the highest level, as I mentioned, Memorystore provides a fully managed Redis and Memcached service. The service is built on open source Redis and Memcached, which means you can easily lift and shift your applications with very minimum effort. The other thing that we enable is that maintaining a caching infrastructure is not easy, especially when you have to maintain a highly available caching infrastructure. So if you were to do it yourself, then you will have to maintain a proxy layer, you have to manage all the VMs, you have to make sure that you patch the VMs, etc. And with Memorystore, we take care of all that for you with our own health checks, automatic failover, monitoring, etc. And on top of that, you get the Google Crate security, where we ensure that the infrastructure is deployed in a very secure environment, where we use private IPs and you have restricted access to specific networks, etc. So overall, with Memorystore, you get a fully managed service that is highly available and also highly secure. And with that, you don't really have to spend time managing your Redis and Memcached infrastructure. You can just focus on building your applications. So let's take a closer look at some of the capabilities that we provide for Memorystore for Redis. So Memorystore for Redis comes in two flavors, basic tier and a standard tier. The basic tier is a standalone instance of Redis. The standard tier is a highly available instance of Redis with a primary and a replica. We support up to 300 gigabytes in dataset size, but the key thing that I want you to note here is that both the tiers are essentially single primary. So that means we don't support scale-out architecture yet. So the QPS that Memorystore supports is limited to what a single primary can support. So when you architect your application, that is something that you should keep in mind, and I'll talk more about that in the best practices section. Apart from that, we provide backups. So if you're using Memorystore as a critical or primary store, you can take backups of your data. So in case of catastrophic failure, you can restore from the backup. And we support multiple versions, including Redis version 5.0. We've also been working on some new features over the last few months. So we have shipped Redis version 5.0, but one of the other key features that we have shipped is support for shared VPC. So if you're deploying applications and service projects and you want to deploy Memorystore using a shared VPC network, you can do that today. So before this feature was enabled, you were not able to deploy Memorystore instances in service projects. You had to deploy it in the host project, but now you will be able to do that. One thing to note here is that this feature today is only available as part of G-Cloud. We are working on the UI, but if you look into the documentation, you will see the steps that you'll have to go through to enable shared VPC for Memorystore. And lastly, we also enable support for VPC service controls. So if you're using VPC service controls, Memorystore works very seamlessly with it. We are also excited to announce that we are providing support for Memcached as part of Memorystore. So what we heard from customers is that there are a lot of Memcached deployments out there for legacy applications, and even for some new applications, customers would like to use Memcached. And with the support for Memcached today, now you have a fully managed Memcached instance that is available with Memorystore. The Memcached instance is a scale-out architecture, so we support up to 20 nodes. You can scale from 1 to 20 nodes, and you can have individual shards up to 256 gigs with 32 vCPUs. So we provide a lot of flexibility in terms of shaping your cluster for the different types of application workloads that you may have for Memcached. One of the other key things that we provide as part of the service is the discovery endpoint, which allows you to basically discover all the nodes in the cluster from an application perspective. So that way, when you're scaling your clusters in and out, you always know what your topology looks like, and you don't have to basically change your app configurations when you scale your clusters up and down. So that's a very convenient service that allows you to minimize the amount of work that you need to do whenever you do scaling of a Memcached cluster. So we are super excited about enabling Memcached for you. We are currently in beta, and we will be going GA pretty soon. Okay, so we touched upon a few things. We touched upon why caching is important. We touched upon some of the benefits of using Redis, and we talked about Memorystore. But the key thing that I want to talk about for the remaining time that we have in this presentation is about the use cases and patterns, and based on that, what are the best practices that you should follow when you are deploying Memorystore? So let's take a look at the use cases and patterns. So the way we look at use cases is when it comes to Redis especially, Redis supports a wide variety of use cases. So from a simple web content cache or a database cache to distributed log, recommendation engines, threat detection, fraud detection, whatnot. So there are a wide variety of use cases that Redis is used for. But the key thing to understand is that each of these use cases maps to 4 different, what I call caching patterns. And the caching patterns essentially determines the behavior that is expected from that caching layer for that particular use case. So we see 4 different caching patterns: the ephemeral cache, the capacity cache, the transient store, and the primary store. And I'll talk more about the characteristics of these patterns in the next slide. But along with the patterns, there is also the workload pattern, which essentially determines the scale in terms of data set size and the QPS, the read-write ratio for the application when it comes to accessing the cache, and also the payload size. So the combination of the workload patterns along with the caching patterns determines what type of deployment you should be doing for your particular use case. So let's take a look at the different caching patterns and what that really means. So ephemeral cache, you can think of it as a very simple cache. If the cache goes away, you can rehydrate the cache from a backend store. There is no real impact to the application except for maybe a small performance degradation that is not significant from an application perspective. And for these kind of use cases, it may be enough to just deploy, a Memcache or the basic tier of Redis, which is actually very, very cheap. But when it comes to the transient store use case, it becomes a little bit more interesting. So you have a use case like session store where you want to store the keys for a certain amount of time, but you want the keys to be available for that period of time, because if you lose the key, then the user experience suffers. Again, it is not catastrophic, but again, the user experience can get impacted, which can also translate to bad customer satisfaction and customers probably leaving your service. So you want to make sure that when you have a use case like session store, your keys are highly available. The primary store becomes an even more interesting use case where it is a primary store that is backing for example, your front-end website, and that data doesn't exist anywhere else. The data is typically processed by offline processing during the day, and it is ingested into a Redis instance, and that essentially acts as the primary store for the applications using it. So it's super important for that layer to be highly available. And for that particular use case, it is also important to ensure that the instance is very highly available, but you also want to ensure that the data is backed up in case there is a catastrophic failure so that you can recover using the backup when the failure happens. And lastly, capacity cache is interesting from the perspective of how customers deploy the cache. So one of the key things that capacity cache is used for is to basically front a database and to ensure that the backend store is not impacted as much. So what that means is that when you deploy your capacity cache, you want to split your key space across a large number of nodes, and so that even if one or two node fails, the impact on the backend backend database is constrained, and you don't really get into the thundering herd problem. So this is where the Memcached deployment can help, because now you can spread your data across a large number of nodes and minimize the blast radius if a node goes down. So these are some of the 4 different caching patterns that we see. So what I want to talk about now is if your application use case fits into one of these caching patterns, what are some of the best practices that you should be following to ensure that you're running the Memorystore instance optimally for your application workload? So the first thing that I would like you to do is to understand and follow the memory management best practices for Redis. One of the things that Redis is notorious for is poor memory management, but as a managed service, we do a lot of things behind the scenes to ensure that we take care of some of the inefficiencies in terms of memory management that happens in Redis for you. But having said that, it is super important for you to follow the best practices and especially monitoring the right metrics to ensure that your instance is running optimally. So let's take a look at some of the metrics that you should be monitoring. So there are 4 key metrics from our perspective that you should be monitoring if you're using Memorystore when it comes to memory usage. The first one is the system memory usage ratio. The system memory usage ratio basically tells you how much system memory is getting used in your instance. So system memory also includes memory that is consumed by memory fragmentation. So if your instance or your workload is causing a lot of memory fragmentation, then the system memory usage ratio will tell you whether the fragmentation is high or not. So you absolutely should monitor system memory usage ratio and ideally set a threshold of about 80% so that you can start right-sizing your instances once that threshold is hit. The other one is memory usage ratio that basically tells you whether your deployed instance is basically being used optimally from a data usage perspective. The next one is also very interesting and something that we introduced recently, which is the time and system memory overload. So what happens behind the scenes is that we have put a cap in terms of system memory beyond which we start blocking writes. So when we do that, the whole idea is that we ensure that there is enough system memory available and the system will not go into an unstable state or crash. But the experience that you will get when you hit that limit is essentially out-of-memory errors on your applications when you try to do writes. So one of the things that you want to monitor is your instance getting into that condition or not, right? It could be that there are some peak workloads where you briefly get into that condition, but then the steady state is actually okay. But it's something to keep monitoring, which will allow you to determine whether you need to go right-size your instance or not. And lastly, evictions is a good thing to monitor to ensure that if you have eviction policies set where you expect the keys to be evicted, you want to monitor that either the TTL is set or the keys are getting evicted so that the memory is managed optimally. So we highly recommend that if you're using Memorystore, you always monitor these metrics and set thresholds, or rather alerts, that can proactively tell you whether your instance is getting into a bad state or not. So once you have done the memory usage best practices and the monitoring around that, the next thing you want to do is, based on the signals that you get, you want to be able to right-size your instance. So like I mentioned earlier, the system memory usage ratio is a very good indicator of how well your system or instance is performing in terms of memory consumption. So if you go beyond 80%, what you would want to do is you want to right size your instance by lowering the max memory flag, which we have provided as a gcloud option, which will allow you to give more overhead for the instance. This is super important, especially when you are doing things like backup or you are scaling the instance often. Because when you do a backup or when you scale the instance, we do kick off an RDB process, which essentially is a child process that we spin up that can consume even double the memory that you're using depending on the write rate on your instance. So especially if your instance is a write-heavy instance, we highly recommend that you provide more overhead by lowering max memory to ensure that operations like backup and scaling can happen successfully. So that's about right sizing the instance. So just to recap, monitor your memory management best practices and right size based on the thresholds that you see for system memory usage ratio or the metric around time in out of memory condition. And finally, I just wanted to touch upon some general best practices that you should be following, especially for the primary store use case. So one of the things that I mentioned earlier is that the memory store instances today, both basic and standard tier instances, are single primary, meaning all your application queries are going against a single primary. So what that means is that you want to be able to run your benchmark for your application and understand whether the QPS, especially the QPS, is hitting the limits. The other thing I would say is that if you have a write-intensive workload, meaning if it is 80-20 reads versus 50-50 read-write, you really want to monitor your memory usage, and follow the best practices that I mentioned in the previous slide. It is super critical you do that so that you can keep your instance right size. And not only that, you can also determine whether you're hitting the limits of the memory store instance. One of the ways you can hit the limits of the memory store instance and determine whether you're hitting the limits of the memory store instance is by monitoring the replication lag. So if there's a lot of writes and if replication is not keeping up, then what can potentially happen is that during failover, you can lose some keys that has not been replicated. And you can basically run into scenarios where there's a lot of key space loss if the replication lag is too much. So you basically want to monitor that. And lastly, if you're using it as a primary store, you absolutely should take a backup of your instance. We have published a paper on how to schedule backups using Cloud Scheduler. So that is published in our solution website. And we have also published a solution paper around best practices around performance for Memorystore Redis in general. So I'd highly recommend if you're using Memorystore today or thinking about using Memorystore that you follow the best practices around memory management and you monitor the metrics that is recommended and also learn how to take actions depending on what the metrics are telling you. So by doing that, we are essentially being proactive about ensuring that the Memorystore instance run in a stable state. And it also, more importantly, allows you to determine whether the Memorystore instance is actually suitable for your workloads. In some cases, if you find the Memorystore instances are not able to keep up, then you will have to shard your Memorystore or application workload across multiple Memorystore instances using client-side sharding. So that hopefully gives you a general understanding of what are some of the best practices that you should be following when using Memorystore. And I hope that you find it useful and it is something that you can put into practice immediately. So with that, I just want to touch upon some useful links that will help you understand a lot more about what I've just talked about here. So there's a memory management best practices documentation that we have published. We have published the performance tuning best practices, and we also have published a solution paper on how to schedule backups using Cloud Scheduler. All this together hopefully will give you a great start in terms of running your Memorystore instance optimally. Thank you very much.